This is the architecture of single bus organization that we are going to discuss. PC, that is program counter, is a register that manages the instruction to be executed next.
Now R0 to Rn minus 1 Rn general purpose registers. They hold the temporary data while performing the different operation. Now what is the IR? Now IR, that is the instruction register which store the instructions which currently
MAR, that is the memory address register. It either stores memory address from which data will be fetched to the CPU or the address to which the data will to sent and stored via system bus. MDR, that is memory data register. It is used to hold data that will be stored or fetched from the computer memory.
ALU, that is arithmetic logic unit. ALU performs simple addition, subtraction, multiplication, division, logic operations such as OR and AND. Y, Z, and temp are temporary registers that can be read and written more than once in a single instruction. A multiplexer or mux perform a selection process on two or more incoming signals using data from a control input to combine the incoming signal on one or more output line.
We will be executing an instruction to add the data of R3 into the R1 and store it in R1. Execution occur in the following step. Fetch the instruction from memory and store it in IR. Then fetch the first operand, that is R3, from the memory. Then perform the addition operation. Then load the result into the R1. Now we will discuss control sequence, as the processor will take address from the PC and store it in MAR through internal processor bus. From MAR it will go to the memory where read function occur, which requires time. In that time we select the 4 from the mux to A and PC content is added to B. Then the addition of A and B is stored in Z. This is required for PC incrementation.
After result store in Z, then it is stored in PC. So the command sequence zout and PCin is generated. After fetching an instruction, the content of PC are updated to point to next instruction in sequence. Then it generates a WMC signal which wait for a memory function to be complete.
After WMFC, the instruction is then transferred to MDR from memory and stored to IR. So the control sequence MDR out and IR in are generated.
as a fetching instruction from memory to IR is done, we have to fetch the first operand, that is the R3. Now R3 will get stored in a MAR and then transferred to memory where read control sequence is generated.
After the reading operation is completed for the R3, the value of R3 it come into the MDR, and after that the value of R3 it will store in the Y register. When this step is happening, the second operation is also happening in the simultaneously. The value of R1 is go and store in the Y1 register. In the fifth step, the value is selected from the Y register and the value of the R1 register is will take it from the MDR, and that the addition is happen and the addition value is stored in the Z register. In the last step of the single bus architecture, the addition value was stored in the Z register, it will take and it will store in the R1 register, and after that the execution will end.